So about a third of our lives is spent sleeping. But do bacteria sleep? We're going to talk about all this and so much more on today's episode of Short Stories of Bacteria. Hey everybody, welcome back to another episode of Short Stories of Bacteria. I, as always, am your host, Dr. K, and I'm here to guide you through yet another story chronicling the lives of the tiny and infamous, and that would be, of course, the incredible, the amazing, and fascinating bacteria. Welcome back, every single one of you guys, to another episode of the podcast. I have a really, really cool story to share with you guys today about bacteria and sleep and dormancy and proteins. We're going to jump into all of that in like 5 seconds. But first, don't forget to hit that like, share, subscribe button if you're listening to the podcast on YouTube. If you are listening to the podcast on some other podcast medium such as Spotify or Apple Podcasts, don't forget to hit that follow button to help support the channel and help support the podcast. Thank you so much, as always, for your support. Now, enough of that nonsense. Let us jump into the actual science for today. And the science for today focuses on sleep, because it turns out sleep is extremely, extremely important, and it's a really complex and interesting phenomenon that we do. If you're doing it right, we kind of mentioned this at the top of the episode, but if you're doing it right, you should be getting approximately about a third of your life should be just spent sleeping. And the reason why so much of our life is dedicated to this is that there are so many incredible benefits and vital processes that our body does through the process of sleep, right? Memory consolidation, that occurs while we're doing sleep. Your body is actively repairing itself while you're sleeping, whether or not you're recovering from a workout or recovering from some kind of sickness. If you're sick or something like this, and then you have this really, really long sleep, you may notice like, oh, I feel a little bit better after I've slept 12 hours, right? Well, it's because your body's been actively recovering and repairing itself during that process. Toxins are actively removed from the body during sleep. Learning. You may think that learning is occurring while you're in the trenches studying stuff, right? But the learning is actually occurring during sleep, when your body is consolidating all of that information into your brain, right? So sleep is extremely, extremely important. We do it, cats do it, dogs do it, horses do it, all the animals do it. Now, there are some examples of creatures that have different styles of sleep. I mean, sharks is the classic example. We're like, oh, sharks never sleep. They're always just swimming around. Bullfrogs have this wild component to them where I believe it's like they can go for full months without actually sleeping. But that being said, even sharks and bullfrogs have different levels of rest. Like, so they'll have a more active phase and then they'll have a more restful phase, right? So sleep is really, really important. We do it. All the animals do it. Excuse me. And we would die if we didn't sleep. Now, one component of sleep is the fact that we have a brain. So if you're an animal that doesn't have a brain, then you don't actually have to do any sleep. So that means that things like sponges, things like jellyfish, and even bacteria don't actually do sleep, right? It's just organisms such as we and dogs and cats and all the other things. That being said, bacteria, while they don't do actual sleep, they have something that's similar to sleep that is called dormancy. Now, all that dormancy is, it's a state where normal biological functions are stopped temporarily, so kind of like sleep, due to a hostile environment. So let's give an example. Let's say you're a bacteria and you're trundling along in the permafrost, or you're trundling along in an extremely cold environment, and you're like, oh, okay, I'm not going to be able to survive, and my body, the cell that I am, is not going to be able to survive in a really strong way in this really toxic, harsh environment, right? And so what they do as a result is they go dormant. They cease all of their normal biological functions, and they just try and wait out that harsh, extreme environment. Okay, that's bacterial dormancy. And then the idea is that over time, once the environment changes, then bacteria can come out of that state of dormancy and they can trundle along like nothing ever happened, right? So that's point number 2. While bacteria don't sleep the same way that we do, they do suspend their normal biological activities through something called dormancy. Now, you could be asking, you could say, oh, gee, Dr. K, how is it that bacteria go dormant? How does it actually happen? And that's a really, really good question. There are a lot of folks that are studying bacterial dormancy. And in fact, there was a recent paper that came out in February And there was a group of researchers out of Newcastle University in the UK, and they actually figured out this really, really cool aspect to bacterial dormancy. Now, and they actually did it accidentally, which is always a fun thing when this happens in science, when scientists accidentally discover something really cool. But anyway, before we jump into the accidental information that Newcastle University identified, we should talk about what exactly you would have to do in order to shut down normal biological functions in a bacteria, right? Now, the best place to start with this, obviously there's a bunch of different aspects to totally shutting down the bacteria. But one of, if not the most important component of this, has to do with regulation of proteins. Now, proteins, we've talked about this many, many times in the show, but just to re-emphasize this, proteins, you can think of them as like the workhorses of the cell. If we consider the cell to be like a building, then proteins are all the different things that are found in the building. You can have a protein that correlates to a computer. You can have a protein that correlates to a window, a protein that correlates to a door. So proteins represent all of the different components that you could find in the building, right? And now all these different proteins, they have a very specific structure, and they have a very specific function that emerges out of that structure, right? But they're really, really important. Now, as it turns out, proteins are always in a state of flux. You don't just make like one protein and then that allows you to carry on as a cell for however long you survive, right? Proteins are always in a state of flux. Proteins are always being degraded, and proteins are always being resynthesized. Now, what that means is that there's a whole bunch of energy that goes into maintenance of proteins. It's a phenomenon called proteostasis, maintaining the proper amount and style of protein, right? And tons of energy from the cell goes into maintaining these proteins. In fact, it clocks in at a whopping 50% of the total amount of energy from the cell goes into maintaining the protein. That's a ton of energy, right? Now, if you were a bacteria and you wanted to go dormant, then this is point number 3. If you wanted to shut down the cell, one of, if not the most important thing you could do would be to shut down protein synthesis, because you're spending so much energy around protein synthesis. Okay, so that's the third point. Let's go back to our researchers from Newcastle University in the UK. Now, how this worked is this group of researchers, they extracted a batch of bacteria from some frozen sausages that they found in the Arctic. I also have questions about this. I'm sure you have questions about this. I don't have much more information than this off the top of my head. All I know is that they were in the Arctic. Within the Arctic, they found some frozen sausages. Within said frozen sausages, they found some bacteria. And so they're like, look at these frozen bacteria or sausage bacteria. Let's look at them a little bit closer. So they extracted those bacteria from the frozen sausages in the Arctic and then brought them back, thawed them out, and they were wanting to study them a little bit more. Like, okay, what's going on with these now thawed sausage bacteria? I believe this initial study, I'm just off the top of my head, I believe this study was associated with climate change initially. But that's neither here nor there. They have this bacteria and they wanted to study them a little bit more. Now, the main researcher on the paper, it turns out that what she accidentally did is she left these bacteria in an ice bath for a little bit too long. So even though they had just thawed the bacteria, then she put them on an ice bath for a little bit too long, and that made them go dormant again. Now, it's likely that there wasn't a whole lot of this frozen sausage bacteria to go around. So because they didn't want to waste the experiment, because they didn't want to waste this resource, they went ahead and they just continued with their experiment, even though they had a totally frozen sausage bacteria. Now, when they looked really, really closely at that bacteria using something called cryo-EM, what they did is they found a particular protein, right? And they called it balón, which means ball in Spanish. And this particular protein, balón, had wedged itself right in the middle of the protein-making machinery, right? And what happened is when balón wedged itself in the protein-making machinery, it totally shut down protein synthesis, right? And so what the researchers did is they were like, oh my gosh, this is a way that bacteria can then shut down protein synthesis. And so they were able to build out a little model. And so it looks a little something like this. Let's say you have this particular sausage bacteria. It runs into an extremely cold environment, say the Arctic or a frozen sausage, right? And then what that does is once they sense that environmental signal of extreme, extreme cold, this activates balón, the protein. And then once ballon is activated, then it runs into the protein synthesis machinery and shuts it down. Okay, and this is a way, and this is a component then of how bacteria can go dormant, right? So what the researchers did then is they identified this mechanism by which they were able to induce, or they were able to figure out how dormancy might be occurring in this particular bacteria. So point number 4, this Arctic bacteria uses a protein called ballon to shut itself down when things got too cold. Now that's really, really cool. And what's even more cool is that this ballon protein, it's found all over the place in bacteria. And it turns out it's estimated that about 20% of all cataloged bacteria have this protein, right? That's a lot of bacteria. We've identified tons and tons of different bacteria, and about 20% of all these cataloged bacteria have this protein. Now, what this suggests is that there's tons and tons of bacteria then in the world that, number 1, can and do go dormant, and that, number 2, use this mechanism of the ballon protein in order to go dormant, right? And what that also might make you curious about is if all these different bacteria have mechanisms to go dormant, and if this, and in particular, they use this mechanism, it's likely then that there's tons of bacteria right now, maybe even in our environment right now, that are currently in a non-optimum environment and are currently dormant, right? And they're just be waiting for some kind of change in the environment in order to wake out from their slumber. So let's wrap this up. Number 1, sleep is incredibly important, and we would die without our sleep. Point number 2, while bacteria don't have sleep the same way that we do, they do suspend their normal activities through something called bacterial dormancy. Point number 3, if you wanted to shut down the cell and induce dormancy, you have to shut down protein synthesis. And finally, point number 4, this Arctic bacteria that was found in this Arctic sausage uses a protein called ballon in order to shut itself down when the environment was too extreme. So we all need sleep. You and I need sleep. Everyone needs sleep. And while you and I might use a nice cup of tea or something else as a way to induce sleep in our own lives, bacteria have to do something a little different, and they use this crazy protein called ballon in order to stop protein synthesis. But anyway, guys, that's what I have for you today. Thank you so much, every single one of you guys, for tuning in for another episode, and I will see you guys again next week for another episode of Short Stories of Bacteria.